Key Negotation of Bluetooth, knob. Researchers, they realized that there was a mechanism in the standard to negotiate or to force low entropy key negotiation. So Bluetooth allows for varying levels of key entropy, and these guys were able to figure out that you can unilaterally force low entropy and thus create a key that has such low entropy that a brute force crack attack is trivial. So they showed this on 14 chips and 21 devices. So how does it work? The Bluetooth Link Manager protocol of the two devices negotiates the entropy level, and that's done prior to authentication. And so they can use anywhere from 1 to 16 bytes. 16 bytes is pretty secure. 1 byte is only 256 possibilities, so cracking becomes pretty easy. The paper mentioned that Bluetooth does that because certain regions have different requirements about how much encryption a consumer device can have. And this is one way to make the standard flexible so that you can deploy Bluetooth all over the world. So since that negotiation happens in clear text, there's a number of ways to subvert it. One is you inject an over-the-air packet that basically says, let's just use 1 byte of encryption. And that's straightforward and works according to their experiments. Another interesting way to do it is with a firmware injection. So suppose that there's a supply chain vulnerability in a Bluetooth chip manufacturer. If they can get firmware in there that just forces all entropies to 1 byte, then the adversary would know that all chips that they've been able to compromise have compromised keys. The net result of this attack is that the attacker has the key and they can see all the encrypted traffic as if it was plain text, and they can inject packets at their whim. As I said, 1 bit, this is 1 byte, that's a typo there. But the attack is able to brute force this 1 byte of 256 possible keys. Another thing they pointed out that was also interesting is that the way the Bluetooth stack works is you have host-based Bluetooth code, and then there's controller-based Bluetooth code that sits on the chip that the host, that is the operating system, never sees and never has to know the details about. This entropy negotiation happens controller to controller. And that's interesting because the host, the operating system, actually has no visibility into the keys or the entropy level used. So there's no telemetry where it would be easy to detect this sort of attack. And so here's a plot from their paper of the compromised devices. You can see everything but the Apple AirPods is vulnerable. The AirPods, it turned out, wouldn't negotiate with less than 7 bytes of entropy, which rendered this attack useless. So Apple did a good job with their AirPods anticipating and having a countermeasure for this attack.